With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Question is, three blocks A, B and C whose masses are m, km and 4m respectively kept at rest on the horizontal smooth surface as shown in the figure. The ball A is given velocity v0 rightward and it collides with ball B elastically. Then ball B collides elastically third ball C. For what value of k does the third ball C receive the maximum speed here? So it is given that A ball initially has been given a velocity v0 such that on first collision with ball here, it says, let's say B here on colliding elastically, let's say after the collision, we can say here ball A and ball B colliding elastically here such that after collision this ball has velocity v1 and this ball here has velocity v2. So for let's say here first collision between A and B, we can apply here coefficient of restitution equation. As for elastic collision, we can say here our coefficient of restitution is equal to 1 and which is equal to velocity of separation, which here is equal to v2 minus v1 divided by velocity of approach, which here is equal to v0. Hence we can say here v2 minus v1 here comes out to be our v0. Now from here we can say v1 will be coming out here as v2 minus v0, that is expressing v1 in terms of velocity of the block B. Now applying here momentum conservation for A and B collision, since no external force acts on the system, so we can say here along x-axis we have equation as initial momentum as mv0 and final momentum we can say here as mv1 plus mass of B here is km, so km into we can say here as v2. So here we can see m and m cancels out and we have velocity of 1 as v2 minus we can say here as v0 plus this here coming out as k into v2 and this here is our v0. So this comes out to be our 2 v0 is equal to we have as k plus 1 into we can say as v2. So this gives us v2 as equal to 2 v0 divided by we can say as k plus 1. So this is the velocity of 2 in terms of v0 and k. Now here it again says now ball B collides with ball C again elastically. So in similar manner we can say here on let's say collision of ball B with ball C. So after this collision we can say here this let's say here km and 4m masses. So this gives us let's say after collision this has velocity as v3 and this has velocity as we can say as v4. So we can say here coefficient of restitution equation for this gives us as E is equal to, again we can say here coefficient of restitution here will be coming out as equal to we can say as 1. So this gives us as our v4 minus of v3 divided by initially C was at rest, so velocity of approach here will be equal to we can say as v2. So this gives us v4 minus of v3 as equal to we can say here as v2. So we can say here we have velocity of 2 as v2 as 2 v0 upon k plus 1. So this comes as v4 minus v3 as we have velocity of let's say 2 as 2 v0 upon we can say here as k plus 1. Now applying momentum conservation for this B and C collisions here. So we can say here initial momentum of the system is equal to final momentum of the system. Hence this comes as km into v2 will be equal to we have as km into v3 plus we can say here C mass has 4m. So 4m into we can say here as v4. So we can say here m cancels out. So this comes out to be our substituting value of v2 as let's say 2 v0 upon we can say here as k plus 1 is equal to we can say here this comes out to be our let's say on simplification we can say here this comes out here as, let's say we need to find here V3. So in terms of V3 we can say here V4 coming out here as 2V0 upon K plus 1 plus we have here as V3. So we can say here this is our K times V3 plus 4V4 gives us as our 8V0 upon we have here as K plus 1 plus we have here as, let's say 4 into we can say here as V3. So we need to find here maximum velocity for B after collision, that is we need to maximize this V3, hence expressing this V3 in terms of these all the quantities. So this gives us, taking this to left side, hence this comes out to be our, we can say here as, let's say minus this here minus of we can say as 6 times K into V0 divided by we have here as K plus 1, let's say is equal to this here coming out as our K plus 4 into we have as our V3. So we can say here this V3 will come out to be our, as we can say V3 is equal to, we can say here, so from here we have V3 is equal to minus of this here is our 6K into V0 divided by here we have as K plus 1 into we can say here as K plus 4. So by the concept of maxima minima we have the variable as K, so we can say here differentiating V3 with respect to K gives us as equal to 0. Now minus 6 V0 is constant, so taking outside, as this comes as dy dk of we have as K upon we can say here as K plus 1 into we can say here as K plus 4 will be equal to we can say as 0. So this here applying, let's say division rule for differentiation, this comes as K plus 1 whole square, K plus 4 whole square, and we have here as K plus 1 into we can say here as K plus 4 into differentiation of K is 1 and K into differentiation of this gives us, this comes as K square plus 5K plus 4. So this comes as 2K plus we have as 5 equal to we can say as 0. Now we can say here on again, let's say here expansion, this comes as K square plus 5K plus 4 minus of this here is our 2K square minus of 5K is equal to we have as 0. Now 5K and 5K here cancels out, so we have value of K square equal to we can say as, let's say 4. So we can say here this comes out to be our K as equal to we can say here as 2. So this is, let's say, our value of K for which V3 will be maximum. Now to check whether it is maximum or not, we can again differentiate this V3 with respect to time, and on substituting K we see that this comes to be negative, which implies that for this K we have this V3 as maximum. Hence K equal to 2 is our final answer.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.